It's a particular pleasure to have this chance. As David mentioned, Daniel was enticed into pursuing this line of work and at least integrating it with his other real passion, which is for art in all its various forms. And over the past several years, he's been a group leader at the Max Planck Institute for Cognitive and Brain Studies in Leipzig. And he and Felicity Callard met each other in one of the many networks that Daniel is a part of, and have learned that their interests are quite convergent and interact in many interesting ways. Felicity comes from the social studies perspective and is currently a tenured senior lecturer on medical humanities at Durham University. And I'll stop taking their time and turn it over to you.
Thanks very much, and thank you so much for the invitation to David and Ed and Gabby, who've hosted us beautifully, and welcome to anyone who might still be watching on the World Wide Web. This is a bit of an experiment. It's a new talk. It draws on some of the material that we've given before, but it is a new talk, so let's just see how it goes. And as Javier has made clear, I'm not a neuroscientist, so one of the things that might be interesting to think about is what kind of collaborations might be possible in these fields. I will leave you to judge through the talk why we have chosen this title. But what we will be covering, certainly, is we're going to talk very briefly about how to tell the short, decade-long story of the rise of the default mode network, with particular attention to the three terms that are invoked: default, mode, and network. Daniel's going to talk extensively about the problems of actually adjudicating what and where this scientific object is. We're then going to address the rise of mind-wandering in relationship to this network, which will lead us on a little bit to creativity and some thoughts about how creativity might be on the cusp of becoming a new construct around which lots of people gather. And we'll end with posing some unanswered difficult questions about the field.
Thank you, Felicity, for the wonderful introduction. So, we've gathered here to talk about the default mode network, and you might guess, if we ask a question after today's wonderful talk so far, what the most popular area of the brain is. You would guess that no doubt it's the default mode network. Well, in fact, you would be wrong in this case. There are other regions that are also very popular. It's not just the default mode network, and that's a bit what this image is showing you here. This was put together using data from Neurosynth, which is Talia Arconi's resource that's openly available online, but as you can see, using the brainmap.org database that's independent from that, you get a very similar set of regions and variation across the cortex in the areas of the brain that have been reported in various studies using various techniques from the past decade. So this is just the regions, and you're seeing how often they've been reported. Now, if you look at across time, what areas have increased in being reported, so linear increases in the reporting of coordinates over the past 10 years, you get a slightly different story. And this is where you begin to see that the default mode network might not be the only areas of the brain that are popular, but it's certainly gaining in popularity more than others. And so one would be wise to jump on the bandwagon now before it's too cool for school, so to say. The question that I think we'd like to go into a bit over the next few minutes is, how has this played out? How has it that we see these peaks of linear increase within this constellation of regions that we call the default mode network? Of course, in the literature, this could be because people are reporting more of the deactivations that are occurring in their studies. But no doubt, as we've seen, the various types of questions that are being asked, the various constructs that are being investigated through cognitive psychology and the way that's brought into cognitive neuroscience over the past decade suggests. These are the regions to keep an eye on. Am I the only one here now? Is that it? It's one of those moments. Okay, I'll keep going, and I'm sure. Oh, that's the guy. So, the emergence of the field, I think.
So the story we want to tell is one that is not a grand sweeping story, but it's actually a composite, an assemblage of different pieces that have come together. And part of our argument is that the very fact that different methods and different ways of mobilizing the term default network and default mode network have been enormously productive in terms of actually spurring the field on. So we've heard a little bit from various speakers about the rise of the field, and arguably we've heard the top half of this. We've heard the top half of the history. So we've heard about Schulman's meta-analysis, which flipped the contrast and started what had previously not been looked at. And we've heard a lot about Raichel's central 2003-2001 papers, which clearly marked the arrival of the field and is commonly thought of as originating the field. But arguably, there's one person, very important person, who we actually haven't heard about at all, poor Bharat Biswal, who is absolutely central to this story. I think it's interesting to think about the ways in which histories get told. So back in 1995, Bharat Biswal was absolutely central in terms of shifting attention to spontaneous, intrinsic activity by looking at how he did a motor task and then also showed that those areas that were correlated during the motor task were also correlated at rest. So in terms of shifting, looking at what had previously been thought of as noise and turning that into the positive thing that became the scientific object to investigate, he is absolutely as central as Raichle. That we told in 2007. I'm going to be really badly behaved now because Daniel has said that the next image is a purely scientific object which Daniel created. Is it going to play if I press?
Oh, it's already been playing.
Has it been playing? In terms of these slow fluctuations, it's also worth pointing out that is also an art object that is traveling in various art exhibitions in Dresden, in the Wellcome Trust in London. So in terms of thinking about how visualizations of data are both scientific and aesthetic, we can talk more about that. Sorry, didn't obey my instructions. So is it on to you? And then in the crucial turn in 2003, which allowed the top trajectory and the bottom trajectory to be brought together. So default mode and functional connectivity were drawn together by Marcus Grecius's absolutely central paper in 2003. That seems to be absolutely the obvious thing that would have happened, but I think it's really important when we tell the story of the history of science that nothing was preordained, and arguably if those papers had not been brought together by Grecius, we would perhaps be in a very different scientific world today.
So at that point in 2003, we have this link between defining the default mode network as a set of regions that are have a certain function, a specified function, a localized function, and the shift towards being able to describe them as a set of regions that are spontaneously correlated at rest. And there's this convergence of the idea of the mind at rest and the psychological state of rest with the physiological activity of rest. Network as a set of regions that are correlated at rest. And as we've already seen beautifully demonstrated in some of the previous talks, if you move the seed region just slightly in a different place in the brain, you get a slightly different network. At what point are we talking about the real default mode network? It's the question of, will the real default mode network please stand up? And we decided to investigate that at an event that was called Brain Hack, and we brought together people that were interested in the idea of open collaboration for a couple of days in Leipzig, almost 2 years ago now. And Matt Hutchinson, who's now working with Randy Buckner, had the exciting idea of could we run an experiment in 24 hours? And what happens when you ask a bunch of neuroscientists who are sitting around to run an experiment in 24 hours? The question ended up being, could we identify, as neuroscientists, the default mode network across a set of different networks that are presented? And so here's an example of the stimuli that were used in that little tongue-in-cheek experiment, let's say. And of course, we weren't able to jump in the scanner within such a short period, but the idea would be that if you're looking at the default mode network and you're able to identify it clearly, does your default mode network respond better to that, especially if you are a resting state researcher with a sense of, let's say, affiliation with that particular network. What we found, and I'll spare you the details because it was a bit of a tongue-in-cheek project, but what we found was that, of course, it is difficult, especially as you aren't thresholding the data as stringently, to actually identify which network is which. And this was one of the aspects that we were all surprised to see. It isn't as easy as you'd think to know what network we're particularly talking about. And I think that point, the speakers that have already presented have done a wonderful job of showing the subtlety with which we can distinguish this. But across the board, there still is a lot of discussion about what characteristics are we specifically talking about when we label something the default mode network. And I'll go into a bit more about what that means in a moment.
Okay, so this is, if we sort of like reel back a little bit to the earlier studies, I think it's worth keeping in mind because I think this then carries through to today and some of the challenges of today, is what are the actual terms that are in play when the default mode or the default mode network or the default network, three slightly different terms, actually arise, and what are the implicit oppositions that occur. So in the earlier literature, some of the most common bifurcated oppositions are between active and non-active, goal-oriented and non-goal-oriented, and some of these profoundly shift in the 10-year period. Active and passive, and the experimental task and the control task. And each of those sets of terms implies very different things about what actually the baseline might be, what the physiological baseline might be, what the psychological baseline might be. But what tends to happen is that there's an enormously fertile, in some ways, use of a lot of those oppositions at the same time. Which happens all the time in science, which is a sort of wonderful, wonderful thing. But the very fact that those oppositions are slightly different from one another, I think we need to keep in mind in terms of some of the ways in which the science plays out later and how some of those oppositions then get transformed so that where we are now in 2014 is somewhat different from where we are today.
And so we've already discussed this point with respect to the timeline, but just to reiterate, you have this re-identification of the network through functional connectivity, through the correlation of spontaneous brain activity in different regions. And one of the aspects that's shown in this paper that's quite striking is that in some ways it's task independent. So you have somebody resting the scanner, you show them a visual stimulus. Regardless of that fact, if you put a seed region, so if you take a region of interest and look at what parts are functionally connected to the posterior cingulate, you see very similar networks. And so it's suggesting that this is more robust than even the kinds of activation patterns that we're seeing during task, and that there's an aspect of this network that can be identified independent of state. So although at that point it's named the default mode network, in a sense it's independent of the mode, and you see the term default network picked up later on. This seemed like a good point to go into some of the specifics of my own work with respect to trying to understand the anatomy. And what's been funny is that there's this split that's taken place in the field, one could say, between those that are focused specifically on the question of the default network, and then the question of resting state networks more generally. So what kinds of connectivity, the idea of looking at the connectome, different connection patterns, and taking advantage of this phenomenon that areas that are talking to each other, in quotes, are spontaneously correlated at rest, are intrinsically spontaneously correlated. And in the work with Javier and Mike Millam that I was involved with at NYU and continuing now in Leipzig, we had been interested in how you could take advantage of this feature, this subtle distinction in connectivity patterns that one can observe, to delineate between subregions in complex heterogeneous areas of the cortex. So essentially a neuroanatomical question. When are we in one area and when are we in a different area from that as you walk along the cortical sheet? And these are three areas that we've worked on that I'll go into a little bit because each of them does have something to tell us about the basic organization of association cortex and about the points of differentiation that one might be able to describe within the default mode network. To show you what I mean, we'll start with the anterior cingulate. And the anterior cingulate's a funny region. I was not involved in cognitive neuroscience in the 90s, but from people who have told me about what it was like in the 90s, if you were into the anterior cingulate, it was a war ground of what this region was used for. And there were battles in the literature. Is it involved in cognitive monitoring, cognitive conflict, emotional or cognitive splits between that? And things started to come together around 2000, 2003, when a researcher by the name of George Bush, who was busy that year, as we like to say, did a meta-analysis of the literature and was able to show a distinction between an affective and a cognitive component of that. And I mention all of this specifically because in being able to describe the functional role of the anterior cingulate, it was helpful to be able to subdivide it. And the way one of my mentors, Michael Petrides, likes to talk about anatomy, it's like asking, if somebody asks you, where's the best coffee to get in all of the world, telling someone in Europe is not so helpful an answer. If you talk about a specific, maybe Italy, let's say, or maybe a specific city in Italy, that begins to become more helpful in terms of describing where to find the thing you're looking for. And when we talk about the anterior cingulate, or we talk about the default network, to extend the metaphor here, it's helpful if we can be able to talk with more specificity about what regions we're describing within that and have a sense of what constitutes a functionally homogeneous area. So in the case of this particular study, we want to understand how connectivity could potentially give us information about subdivisions within the anterior cingulate. And I won't go into the details of the results from the study except to specify what's of relevance to talking about the distinctions along the medial wall of the default mode network. And if we focus in on three of the seed regions that you see, so if you follow the superior line of seed regions that we looked at on the image on the left, 5, 6, and 7, which are on the right now, you can see that each of those has the characteristic medial wall pattern of the default mode network. Except that you look at S5, and all of a sudden, if you look on the temporal lobe, so on the lateral wall around this area, the red area is absent that's present in S6 and S7. And so you might say, okay, at that point, well, S6 and S7 must be the real default mode network. But then you look along the ventrolateral prefrontal cortex, so this area of the brain over there, and it is present in S5 and absent in S6 and S7. And so you can play this game of trying to pull in all the different regions, but in fact, none of the ones where we're seeding along regions that should consist of part of the default network contain all of them. And it raises that question that, yes, we can localize it down to a certain point, but there's subtle gradients and distinctions that are taking place, as we've seen recently in Bill's great presentation of this gradient along the prefrontal medial wall. If you're looking along the posterior extent, and this is work, this is from a review that was conducted in 2007, where we simply took all of the regions that were reported, plotted them onto the posterior medial cortex, so the posterior component, and tried to observe whether or not there were distinctions. As you can see, there's a distinction between self-referential processing and episodic memory as you move more towards the parietal occipital sulcus, the posterior portion over in the back there. But there's also been support for subdivisions within the posterior medial cortex from the histological literature. So these are folks that are slicing up brains and looking at the various compositions of the cellular layer and architecture within those layers. And there's been a vast literature over the past century, at least the first half of the past century, that's shown distinctions between these areas. It's one of these kind of historical little quirks that we got stuck with the Brodmann map, which is extraordinary for many reasons. But one of the points that he was afraid to draw the line on was where there was division in what's called medial area 7, or what's been referred to as the precuneus over the past day. As you can see, Brodmann does note a gradient within this area. He doesn't place a line there. And so when this map gets picked up by the imaging literature, I'll spare you the drama of the whole story, but when it gets picked up by the imaging literature, it's referred to as this homogeneous area 7. As the precuneus as a whole. But in fact, there have been several studies over the past century that have articulated division in this area. And so one of our questions was, how could we go in and try and understand, again, where there are subdivisions that are related to the network that's defined as the default mode, and is it in fact the posterior cingulate precuneus that defines that? And so we looked into the human anatomy, as well as comparing that to functional connectivity from the macaque monkey. And just to give a very brief overview of what we found, if you look on the more anterior portion, so if you look on the left there's a little blue dot, and if you look in that region, what you see is quite a sensory motor component of it. The connectivity of it is with sensory motor areas. If you move slightly behind that area into the middle portion of the precuneus, you see connectivity to the dorsolateral prefrontal cortex, but not the medial wall. So it's also quite distinct from the connectivity pattern that's characteristic of the default mode network if you're going to include the medial prefrontal areas. And then there's a visual component that extends towards the back. So there's no doubt that the precuneus acts as this multimodal integration region. But whether or not it consists of the defining characteristics of the default mode network, I would raise that as a question. That's in fact what we did with the paper, because if you look more ventral to that within the posterior cingulate, you see a set of regions that would be more characterized as default mode areas. And this is simply a schematic overview of that. Now, Binder and colleagues have a wonderful article in which part of it is this review of the anatomical literature from the macaque monkeys, showing these, say, 7 different components that are interconnected. Not entirely interconnected, but there are portions of them that are. And this helps to explain why in the human literature we might have some of the difficulties distinguishing subcomponents of this. I'm going to move along quickly here, except simply to come to this point at the bottom. And what we're doing here, again, is taking data from the macaque monkey literature. This is track tracing studies where we know the gold standard. We know where the origin and the termination points of these axons lie. And so we can have a strong foundation that we know is not due to artifacts of the particular imaging methodology. And if you look at what's been hypothesized from the macaque literature, you can see this kind of bowing out of connections surrounding the central sulcus, so surrounding that mid-deep sulcus in the brain there. And in the human, which you see in the bottom right, if we zoom in on that, it appears that there's this kind of topology that's consistent. This is, again, a point that's come up a couple of times already in the talks, but I'll reiterate it again to expand it to a further theory of how this organization may be taking place. But if you look at the coloring that's beginning at the central sulcus, so right in the middle of the brain and extending anterior and posterior, you go from yellow to blue to green to red. And you actually see that same pattern, that same topological structure taking place between the networks, about 6 different patches along the cortex, more or less. And I think this is an area of further research to identify precisely how frequently this occurs and where. But the basic idea that has come up is that you have these kinds of similar mappings of connectivity that are taking place throughout association cortex. And so that same pattern of now dark pink to light to kind of maroons and yellows, if you look across the rest of the brain, and this is work by Yo and Buckner and colleagues, you see this similar repetition of connectivity gradients throughout association cortex. And it raises a question of whether or not this is the basic organization that might be underlying the kinds of connectivity patterns that we're seeing in our functional studies. How are we doing on? We should move along? Okay, I'm going to speed through this, but one of the ideas that we've been working with recently in Leipzig is that... Oh, okay. Great. One of the ideas we've been working on recently in Leipzig is that if you simply start from the blue now, and you see this in the Yo map on the left, if you start from the blue and label every point in the cortex by how far it is from unimodal cortex, so how far it is from your sensory, your highly differentiated cortical areas, you start to see something that looks very much like the default mode network. I know. I was very excited to see this. It was a surprise. You may not be, so I was surprised by this. Now, okay. I was surprised. At the same time, there's a problem, and you probably see what the problem is. It's that if you keep going forward, you see a gradient in the prefrontal cortex that simply gets brighter and brighter because it's getting further and further away from motor cortex. This is a problem because it doesn't fit the data that we're observing. You see that little pink area right in the middle of the Yo map in the front. And so there seems to be this exception that you have to make, where you change one aspect of the topology here, and you put a dot in there. And so if we put a dot in there as well, now we get something that looks very similar to the default mode network. So now one can be happy. But it raises this problem of what is this dot? Why is this dot so important? The dot seems necessary for articulating this gradient, this topological gradient that makes it look consistent in terms of cortical distance relating to the default mode network. What's the dot? Is there any support for the idea of this anomaly in the posterior to anterior gradient in connectivity patterns in prefrontal cortex? And one nice piece of converging evidence, and this is all just hypothesis at this point, and I would love thoughts and ideas, but one nice piece of converging evidence for this is a study by Roberto Toro from 2005. And if you simply look at the amount of cortex that is compressed into an area, so if you take the ratio of the surface sphere to how much cortex has been pushed into these cell size, and you look at how that ratio relates to the size of the cortex across individuals. So the question is, where, if you have people with larger brains, do you have more compressed tissue? Do you have a higher degree of surface ratio? And lo and behold, you see it in precisely the same point within prefrontal cortex, where you seem to be having this exception. At first, when I looked at this, I thought this might be somewhere along the intermediate frontal sulcus, areas that we'd identified as being involved in working memory, area 46. It doesn't precisely seem to be that area. It's just slightly posterior of it. It's just at the back end of the intermediate frontal sulcus. And it's an open question, I think, what this exception may be doing there. It's not characterized in terms of the mesonym hierarchies or the rostral-caudal gradients that have been described, but it seems to be extremely important for something about the structure and the cortical expansion that may be related to default mode structure. And it allows us to reformulate the notion of the default mode network, not as a circumscribed, highly delineated network, but as the peak of a set of connectivity gradients that are moving along association cortex. I'd raise that as a discussion point, and it also, as I think Randy beautifully went into this morning, raises a potential, say, evolutionary process by which the pattern that we're seeing here is given rise to by differentiation in cortical areas themselves.
Okay, so switch in the talk. So we've heard a lot about functional connectivity approaches. So let's turn back to the other side of the enormous amount of interest around this region, which is about psychological functions. So if we think that at the beginning, in the 2001 three papers, Raichle papers, that established the field, they raised a range of possibilities about mental activity in the default mode. And they cited various other people's work, including Nancy Andreassen's 1995 paper, which is in some ways a rather forgotten paper, but is also, I think, really fascinating in terms of the emergence of the field. So they said that spontaneous mental activity could be stimulus-independent thoughts or daydreams, task-unrelated imagery and thought, free association, drawing from the psychoanalytic literature, or stream of consciousness, obviously going back to William James's 1890 work. Those were the possibilities that were open then. And so one of the things that Daniel and I and Johnny Smallwood have been interested in thinking about is how the constructs used to explore this unconstrained mental activity have also kind of tightened over the last 10 years. So by 2007, and again, key paper, Mason's paper in 2007, it's that year where you start really getting mind wandering as becoming a very prominent term, as a sort of umbrella concept to think about this unconstrained mental activity. So we started thinking, is that really the case? Does mind wandering rise in visibility? So one of the studies we've done recently is exploring what happens to these different terms by doing various kinds of citation mappings. So we took terms that we knew were getting at analogous phenomena: spontaneous cognition, spontaneous thought, task-unrelated thought, fantasy proneness, daydreaming, stimulus-independent thought, and mind wandering, and looked at the numbers of papers that cited the top 3 cited papers associated with each of the terms on the right, and then plotted it over the last decade. And I think you can see very clearly there's something interesting that happens in 2007. And then something interesting again that happens in 2010 when mind wandering really pulls away from some of the other terms. So if we think about how this ties back to this complicated term default network, again, so we then homed in on the mind-wandering literature within that database, and through a combination of looking at the keywords of the articles that were associated with mind-wandering specifically, we coded the kinds of constructs and focuses of those papers. And again, you can see very, very clearly that cognitive neuroscience gets pulled in. If we remember that mind wandering emerges obviously very strongly in the psychological literature, it's around 2007 that it gets pulled into the cognitive neuroscience literature, and then in particular you start seeing the default mode becoming a really prominent subsection of the cognitive neuroscience literature. So again, thinking about what becomes popular and how different constructs, a psychological construct and a neuroscientific construct, come together. Things might have looked different if different concepts had been used. Again, shout out for the humanities people. Of course, there's a very rich archive of literatures on daydreaming, fantasy, free association, stream of consciousness. There's a very rich archive there to think about in terms of potentially operationalizing other modes of getting at what is going on during these unconstrained activities. I'm going to skip through that. This is also showing how the psychological literature gets pulled in relationship to, so that Johnny Smallwood and Schooler's paper is absolutely central. You can see it in the bottom left, the Smallwood 2006, and its proximity to the Buckner, Fox, Christoph, Grecius, and other kinds of literatures that look at analogous kinds of things are very, very far away and are separated out. Okay, so I'm going to turn back to Daniel at this point.
Okay, so I think part of the discussions that we've been going through quite a bit lately is what is the trajectory the field has undergone? And 3 or 4 years ago when we were looking at the history of the emergence of resting state, it was very much one of these two converging historical lineages. One looking at functional connectivity from this kind of, if you to use the term, a Biswallian kind of perspective of looking at the correlation, spontaneous intrinsic correlation. And the other one was looking at more of a Reichlean type of question about what is the brain's baseline, the static baseline of the brain. What are the psychological functions that are underlying the higher activity we see during this resting condition? And I think there's another way that one could formulate this now when we've seen how the field has evolved over the past couple of years and is still continuing to change. And that's an interest in dynamics that has dramatically emerged really since 2009-10. Around the time where you see this rise in interest in mind wandering, in fact. And if you were to think of the sort of the initial questions being about the function of the brain when it's in its default mode, to the specific functions of this network that we see to be higher in activity during this default mode, to one of trying to understand the experience itself of thinking, because this is really coming down to the question of what are people doing with their minds when they're just left in the scanner to use them the way that they want. We arrive at that question now, and it's a highly dynamic question. Then if you think about the same problem from the other side, from this Biswallian kind of Biswallian perspective, it begins with this question of what are the organizing principles of brain activity, to how can we describe these sets of connections using that activity, and finally to what are the dynamics and what's the meaning of dynamics, and how can we bring these points together? So this convergence of functional brain dynamics and the dynamics itself of thinking is where the field in many ways I think has arrived at right now. And of course we all know what a dramatic challenge is, and you've seen some fantastic research already presented that's trying to get towards ways of methodologically addressing the dynamics of thought with the underlying dynamics of brain activity. But there were certain points that were necessary in order to be able to ask those questions, and certain insights that came from the evolution of these fields over the past decade.
So again, we're moving towards a conclusion, and just a few more thoughts about where creativity might be emerging in relationship to this literature. So going back to one of the slides that I had earlier, a lot of the earlier literature was driven by kind of bifurcated models, goal-directed, non-goal-directed, external, internal. And it's clear from what Daniel's just said that in the recent years, that shift to thinking about dynamics much more carefully has, again, pushed different kinds of accounts of psychological functioning forward. So if we go back, and actually, William James's accounts of attention and stream of consciousness provide multiple, very, very differentiated, granular accounts of different kinds of so-called unconstrained activity. But one of the things you have to get beyond for creativity to emerge in the psychological literature is for this state of not doing tasks being seen as the usual state of brutes. So, he's here saying that, the curious state of inhibition where you're thinking of nothing is arguably the state of brutes engaged in monotonous tasks. So arguably in the earlier phase of the default mode literature, you're still stuck, I think, with some of that legacy of what the mind is doing when it's not engaged in an external task has been given far less attention because of the legacy of behaviorism and the cognitive revolution in psychology, much more interest in thinking about responses to tasks. And again, some of the work that we've been doing with Johnny Smallwood, though I've used one of his earlier pieces here to demonstrate it, a lot of the earlier work on mind wandering was in some ways driven by what it was opposed to. So the dominant terms were things like attention, executive control, cognitive control. So mind wandering got in some ways framed against that, so going AWOL in the brain. And again, a very fascinating negatively driven literature around mind wandering as affectively negatively valenced. Now, again, this obviously, the field I think is enormously diverging at the moment, but I think one of the things that is beginning to happen now is once you've got mind wandering and default mode brought together, the subterranean literature on creativity, which was there, going back to Andreassen's 1995 paper, where she links resting state with consciousness, self-awareness, and creativity, that is beginning to surface more. And again, this kind of mining of older literature, so Jerry Singer's work, which has been central in the re-emergence of mind wandering, a turn to really thinking about how Jerry Singer formulated daydreaming as tied to creativity, a certain kind of daydreaming. I think I'm going to stop there. We're nearly out of time. 2 or 3 concluding slides that we don't really, they raise questions rather than answers. As a historian of science, Hans-Jörg Reinberger, who's one of the most prominent historians of science, has really paid attention to how a lot of the concepts in the life sciences, like the gene, the very fact that they can be mobilized across different communities in a variety of ways can be enormously productive. So one of the things that Daniel and I have been thinking about is this term default mode, default mode network, resting state. The fact that there are lots of different methods, different ways of visualizing, different ways of probing has been incredibly productive for the field. But is that term in 2014 still the most productive concept to use to get at the things that we want to get at? And again, I'm thinking about Nathan's talk and Bill's talk. Arguably, is that concept in some ways going to give way? Final slide.
Oh, yeah, I felt it would be appropriate at this point to harp back to something we can all remember fondly, which is there's a shout out to mirror neurons. And for what, all that they have been through, I don't think there's any doubt that, I don't think there's any doubt that it had an enormous impact on the ability for people to speak across disciplines and for ideas to come together. And sort of, I would raise the question of, in many ways, the default network is allowing us to talk about association cortex. It's allowing us to bring the notion of connectivity between regions to play in trying to understand brain function. And it's allowing us to do that with psychological functions that are far more complex than people would have imagined we'd be able to discuss 20 years ago. And what role does the concept of default network play in enabling that dialogue to take place? And there are points that I think we've seen and points where there is value in breaking that concept up. And there are points where it facilitates the ability to speak together. So you said you would read it, so I.
So obviously the title goes back to Raymond Carver, and so the statement is simply, what do any of us really know about love, Mel said. It seems to me we're just beginners at love. And on that note, we'd like to thank Johnny Smallwood, Michael Petridis, and Alexandros Koulas too. Thanks.
Thank you. Comments, questions? With a coffee break in the offing. Yes.
So I don't know if I have a question, but just sort of to add to the discussion about this. So I trained in neuroscience, but I'm really a practicing psychoanalyst, and so I've been following this literature from a psychodynamic perspective. And what's very exciting to us within that realm is that it seems like now that we're talking about networks that can be more or less identified with particular kinds of capacities or functions, and we can start to talk about how they're related to each other dynamically, we're now in a position, I think, to make a lot of correlations that we couldn't have possibly made even 5 years ago. And so it seems like what is being identified in this literature is that on a very ongoing basis and in a very rapid way, we have networks that are monitoring what's happening outside, what's happening inside of our bodies, what we're remembering, what we're predicting, and using value as an important toggle between what we're attending to, what we're changing, and so on. And so that correlates very directly to what we talk about in sort of psychodynamic understandings of an inner world. The thing that we would add, which even adds a whole nother layer of complexity to this investigation, is that we also presume that we have processes happening out of awareness, unconsciously, that are also affecting how all those networks interact. So I think just building on what I was just curious to hear if you had thoughts about this. It seems to me that in the big picture, that it looks like the salience network, which is getting emotional memory information, visceral information, reward and punishment information, and then connecting to frontoparietal control networks, and also with default mode, is sort of influencing how when and why we're shifting back and forth between attending to the here and now or attending to memory, and also what we might do or not do in any given moment. So I'm just curious if, as you guys have been looking at this literature, specifically kind of the salience of things being a key in what toggles us between the different networks. I don't know if I said that coherently, but there you go.
Yeah, I was thinking of Andreas, and stuff. It'd be interesting to bring in there. Well, yeah, Maggie, I'm sure I'm not going to say anything that you don't already know better than I do about the how that network finds a place. I believe it is Bill Seeley's work, the one that brings that to play in terms of the control and back and forth. But I'm sure that you would have more interesting points to bring up about this network. One of the questions I guess I would raise, is basically the distinction of these is different. And I would just raise the question here. The idea of here we are in one network, and at that point we transition to another. And is it possible that we're simply talking about the recruitment, or that individual areas are joining and linking up with adjacent regions, that we can then describe connections between them as being a network? And so simply saying salience network, is it possible that we're really just talking about gradients along between adjacent cortical areas that are talking to each other? And that's really a question. It could very well be a wrong hypothesis, but at this point the literature is very much situated, and we have these different sets of networks that are talking to each other and somehow meeting each other like different territories. And perhaps those boundaries between the territories are a bit more ambiguous or fluid or plastic than they're described at the present moment. So I would just raise that. But
very brief second point. I mean, what to me psychodynamic thought has done is posed other ways of understanding the relationship between the internal and the external world, such that when you're operationalizing a paradigm and certain images are seen as not relevant to me or relevant to me, I think psychodynamic approaches might offer different ways of deciding what things are relevant to one and what things are not, because the way in which certain kinds of images or objects get cathected and become relevant is a different model from a lot of the conditioning and other kinds of psychological approaches. I think there's a lot to think about there. I won't say any more now.
The notion that the concept of the gene is profoundly important has been transformational in our society, and yet there is no definition of a gene. Shows how far we can go without precise definitions at the same time that we have to struggle to define and to understand where those imprecisions may be confusing. And I think that point is worth highlighting, that we have both of those dualities, certainly in this field, that we can speak with confidence about the reified default network, because it emerges so robustly from statistical observations, and at the same time, it is extravagantly dynamic and bashful, and like a subatomic particle, can't be really pinned down in any one individual with precise boundaries. What we have is a statistical sort of a range of probabilities of this territory is more or less high probability of being designated as default network under this particular analysis at this time in this scanner. And huge overlap amongst all the people in this room about where those are, but huge differences among every one of us from second to second as to where those boundaries would be placed. So it's a fascinating recapitulation of that kind of both universality and intense variability. So with that, let's revive ourselves with caffeine and other substances and come back for the last two talks.